Hello, YouTube, and welcome to my series I've labeled Rubber Duck Programming. I was inspired recently by this concept of programming to an inanimate object, and I think it just spoke to me. I think it works for the way I learn. It works very well. For most people, teaching is the best form to learn and solidify concepts in your head. Probably from related to evolution of years and years and years of teaching children and teaching others and passing on your traits. It just seems to be the best way that the brain likes to upload and keep concepts and information. So I'm selfishly putting together this series to do that for myself. I've gone through learning algorithms a few times in my career where I focused on this. And, after years go by, it does, without using them on a regular basis, it does kind of get fuzzy. So I'm selfishly creating these videos so I could go back to them, teach anybody out there who wishes to learn. I really, truly do hope that someone gets something out of this. If I'm not fast enough, feel free to, speed up the video to get to the parts that you want to get to. But I wanted to start with a little introduction to let you know my motivations. I'm a 20-year seasoned web developer, a glorified string handler working for companies like Expedia, Air Canada Vacations, and a startup that was called Conceptus and bought by WebMD. So I do have, and I love the subject. I really do. I did from the day I started and I built my first web page. So I got hooked by the bug of coding, and I will be a coder as long as I can move my type on the keyboard. I just, it's something that, when you find what you like to do, you get lucky. So why algorithms? Let's get to it. Why algorithms? They obviously they're the fundamental building blocks of problem solving. That's where it's at. They help you sort of be able to hear a real world problem or requirement, and they sort of help tune your brain and how you may solve it. Even if you're not writing the algorithm itself, you may use a library to write that algorithm. You may use an AWS service to implement that algorithm. But still, knowing, and especially in this world of AI will probably the AI is going to write the algorithm in seconds. Okay, so, but you still need to know how to read it. You still need to know what it does and why. So I'm going to try to focus on that. In this series is the why of each algorithm, more than even the algorithm. I think that's even more important in this new era of programming. So that's my motivation. And another point I want to make is we should honor those who came before us. I love that concept that learning algorithms is honoring those that came before us. A lot of these algorithms took years or lifetimes to make efficient. I mean, they could have been written quickly, but to make them great and make them simple, there's been a lot of really intelligent people in the past that I think it's interesting mentioning that even though they're not ours, they don't have to be. They can become just a tool in your toolbox. They belong to sort of the collective intelligence of all coders out there. So just make them part of your toolkit and be a better developer. So enough philosophy. Let's code. Let's stop talking. The first one I'm going to demonstrate here is HashMap. It's the go-to. It's interesting. It's ironic. It's an ironic data type. Or a structure, it's a data structure, data structure that I should call it, is that because it's so simple. It's just a key value store. But, there's so much out there that, like in computer science and in coding, there's so much magic behind just the key value store. It averages O to 1 in big O notation. It's basically an instant lookup. It's an instant insert. And an instant delete. So it's absolutely incredibly powerful. It's used at the CPU and the CPU registers. It's used in RAM to store key value pairs in memory. It's used in LRU caches, least recently used cache, which is just a hash map that has a capacity where you knock off the end as you don't need it. When it's used in databases like Redis and Cassandra. It's just it's such a simple idea, but it talks to the thing is it talks to the CPU so well, from the code that you write through to the OS, down to the raw hardware. It just is fast. So I wanted let's write our first hash map here. I'm using Java. This is the code that sort of ran most of the backend up until, it ran a lot of backend web applications for a long time. Now many other languages have taken over, like Python and Node.js, which Python and JavaScript and the engine of Node.js. But I really do like and to learn other languages like JavaScript, Python, and Rust. And I'm always learning when I can. But I know Java the best, so that's what we're going to do this series on. So we're going to type the hash map with a key of a string and a data type of an integer as the value. This almost feels like the hello world of data structures. So I have to do it. Let's run it. And null, true. Oh, what did I do? Maybe on purpose. I put the value and I didn't put the key. So we got to put the key, because you see here we got null on the response, and true. Yes, it does. The map does contain banana. Run it again. There we go. So we get the key out. We get the key apple, and it retrieves 1, and we check that the map contains banana. Some other things that you can do with a hash map are you can put another hash map within this hash map. You can only put the key value pair if the key is absent. Remove items from the hash map entries. You may replace a key value pair. So you check the size. There's a lot of powerful functions that you will definitely be using. So kind of go through the hash map and play with it for your own. Let's iterate over what we have here. You can iterate just over the keys by calling the key set. If I comment out this, you can see if we iterate that it'll loop over just the keys. Sorry. You can iterate over the entry set, so you can see both the key value pair. So you see banana equals 2, banana equals 1, and then from here you could say, just get me the value, or just get me the key in the loop. So very powerful, very easy to learn, very fun. So that's it for today. So we started very easy on purpose. The goal is to build confidence and intuition before we move to harder topics. Remember, every expert was a beginner once, and this stuff you will need to revisit. You'll see as the more complex algorithms, as we review more complex algorithms, you will need to review them from time to time. And that's it. See you in the next video. Keep coding, keep learning, don't give up. Thanks for watching.